Hey guys, Brian here. Welcome back to this old hoist. We're going to do some figuring today. I've managed to somewhat get this apart. Pretty much destroyed most all of it. Getting it apart. This brake housing. No way to access this shaft. Anyway, the shaft froze into the gearbox. It's rusted in. The gearbox does still turn. Okay. Best I can figure, it's about a 48-to-1 reduction here. It's kind of tough shape on this seal surface. I'd have to find or build one of these motor mounts again, which apparently also acts somewhat as the bushing. So it fits tight on that shaft. I assume there was an oil seal in there. Can't say for sure. Anyway, I was able to get that off and get that apart. I'm not sure the torque rating on this box, what it's rated for. So I'm not sure if it's sized correctly. The other night I did some rough calculations and decided that I thought maybe it was under horsepower to lift the 15 ton. So we're going to do that again here today. And what we need to know is the total reduction. So we know this is 80 teeth, 14 teeth. So now we can calculate this gear reduction. And then that's 48-to-1. So we know that motor reduction. And we've got 8 parts of cable over here. It's a 4-block on the bottom. So the load's divided by 8. And then what we need to know here is this drum diameter, because that's related to the torque it takes to pull the cable, and we'll also use it to figure how fast the cable will pull. So let me get this measured. Pretty much 51 inches around would be a good nominal value to use. Not super critical, but so we're going to go with 51-inch diameter. So this key is turned this way, and we've got that up part way. So anyway, let's count here. 1 turn, 2 turns, 3 turns, 4 turns, 5 turns, 6 turns, 7 turns, 8 turns, 9 turns, 10 turns, 11 turns, and 12 turns. And I'm going to say that that's moved about a quarter of a turn. So times 4 makes it 48. Bailey's come to check. Be sure we're doing it right. The other thing we want to know is the distance between the worm and the gear here. like about 3 3/8. Looks like an 1 3/8 box shaft. To use this, we'd have to get this shaft out of here, get this cleaned up, which probably means pulling this box off, taking it all apart, resealing it. So I'd say that seal would probably leak even though it's just got grease in it. So we may end up doing a mechanical deal after all, because I'm not sure how much this is going to be salvageable, and it's going to be pretty pricey to put it all back. Got probably get new contacts. Definitely have to have this brake assembly, because I had to destroy it to get it off. There's no holes in this piece, and it covers the whole shaft. There's no way to get in there to get that loose. If somebody put never sees on that when they put it together, it might have got it apart, but no way to get it apart like that when it won't come apart without tearing it up. So, and then the motor, it does turn okay, but I'd say it's probably no good either. So we'd have to buy a motor and a brake assembly and build a flange housing for this, or we can build a bearing mount, put on a shaft, have to come up with 2 hand wheels, and well, it doesn't have to be 2, it could just be 1, be single speed, but be better with 2. You won't have to pull as much chain, and build these 2 gears. That's the next thing we need to know, is how far apart are these shafts. It's like 9 inches. Yeah, 9 inches. That could be quite a job too. They've got this coupler welded to this shaft, so that could be a big pain in the ass getting that apart. Well, it wouldn't be too bad because these bolts, I could probably just take these bolts out, lift this all off, still assembled, then cut this off in the lathe and get it cleaned up, make the gear go on it, and make the gear go here. We also have to put a brake assembly in, which would be a pawl ratchet type. I'm going to say it was originally mounted down here. You can see where somebody's torched off a bracket. I'm going to say that's where the original brake pawl stood up that locked the brake to hold the load. Wish I could find some gearbox info on this thing, but I don't see any name on it. It's just got something on the side it's mounted. It'd be kind of goofy, but no tag, no name. Looks, they didn't want you to know. But anyway, that's where we're at with this. So let's go take a look at some hoists, and then we'll do some math and see what we got going on here. Okay, so let's take some look at a couple of various chain hoists we have here in different vintages, and what possibly could be done to retrofit this stuff onto the crane to make it work if you decide to go the manual way. So let's start with the oldest one here. This is a 3-ton right, and it's a double fall chain, so it's 1.5 tons on each chain. Split up, And you can see the construction of it. Pretty typical of these older cranes. It's got cast outer gear for the planetary, and got the pinion in here, and the planets going around the outside, and it's a double reduction. So you got a little gear turning these bigger gears, and then they step back to the small gear into the sun, and then this carrier is what actually moves the load. So that's what actually is hooked to the chain inside. This is the same thing on my 3-ton Yale that's a single chain. So this one's got to lift twice as much, so that's why all these gears are bigger and beefier, and we've got a beefier carrier on it. This one is actually the one that I've got that's got close to the right size hand wheel that I need for my crane. But it's a real nice hoist, and I really hate to take this one apart just to get the wheel off of it, because it's kind of one of my favorite cranes. You can see how thick the wall is in this gear versus this one. It's just a really heavy made unit. Nice piece. Of course, I've got another Yale. It's just 1.5 tons. It's over there under that hose. It's the same style as this, but it's got a built-in trolley on it, so I'll use it on a beam down there. And then I've got this little right here. This is 1.5 tons. Funny that this is 1.5 tons in the 50s. That's 1.5 tons in the 30s. So you can see they figured out they had it a little overbuilt. And this is what we got here. I could use this stuff here. Would be pretty easy to take apart and use as a reduction unit, since we've got a welded on gear here that could be used. I'd have to calculate what the reduction here is. But one option with these small ones I've thought about would be I can mount this in between and then run this chain here in a loop, and get another one of these sprockets and mount on the shaft on the other side, and just pull this chain around and around and around to drive the thing, and use this reduction and this hoist and the brake built into this hoist to manually function the crane. So that's an option. Or I could take this out. Looks like it's a spline shaft down in there. Could take this piece out and make a sprocket to go in there, and use a double roller chain or something like that to hook the two together to drive it. I'd have to look I have to figure what the reduction is on this as to how much pull it would actually have. I think 500 foot-pounds would be plenty. 450 I think is what I calculated at rated load it takes to pull the hoist on the shaft without the gearbox that's on there now. So let's go do some calculations. And we'll see, this one here is pretty small, so it would actually fit in the crane. Not sure exactly how I would mount it. This is welded on. It's all welded together. Looks like. Yeah. I don't know that I can get it apart. These got nuts on them. Studs that come apart. So I could take this front half off maybe and retrofit that on. Similar thing, I guess, but this one's too big to fit lengthways, in there to use this part to drive it. That one there would fit. The chain's overkill on it, and I have to figure what the speeds are. So that's the options. Let's go take a look at the calculations and see where we're at. Okay, we'll see if we can go over this here. This is on our BR Hoist, which is a 15-ton rating, or 30,000 pounds. So we got 30,000 pounds divided by 8 ropes to the block. It's 3,750 pounds per rope. Our drum circumference we measured at 51 inches. Divided by pi, 3.14 means it's 16¼ inch diameter. So 16¼ inch diameter divided by 2 is 8 1/8 radius. So the load to lift is the load times the radius is equal to the torque it takes to turn the shaft. So we got 3,750 times 8 1/8 is 30,468.75 inch pounds. So you divide that by 12 and it's 2,540 foot pounds. So a reduction at the winch is an 80 tooth and a 14 tooth, which is a 80 divided by 14, 5.714 ratio. So the torque from the gearbox is equal to 2,540 foot pounds divided by 5.714 is 444.52 foot pounds. And then our worm gearbox is 48-to-1 reduction. So we got 445 divided by 48 is 9.27 foot pounds input for the rated load. Now I will say that that's assuming no frictional losses, which is kind of bogus. Probably on a worm gear, maybe 80%, could be down as low as 70%. So we need something over 10 foot pounds at least to pull the load. And from what I looked up online, that 1.5 horse motor that was on there wouldn't have been able to do it. So I don't think the hoist retrofit could actually pick up the rated load. So we're going to have to do something different on that. The question now is, do we want to put the original gears back on, which this is all wrong. The original gears I've looked for be a 6DP 12 and a 96 would work. On Amazon they're $57 and $592. Yeah, I could make these gears, but I couldn't hardly buy the material to make this one out of for the money, so I don't buy enough 16.5 inch diameter bar stock to make that worthwhile. So that would be an option, but you'd still have to take the chain hoist apart in order to get the wheel and a lock pawl and a brake to make this work, to put it back, or have to come up with a different motor that can generate enough torque to do the other deal. I will show you here. I was able to find online after a lot of research. This is the original hoist unit. This is a BR hand crane, and that's what it would have originally looked like right there with the hand wheel on it. Now that one's not quite as many tons, so it doesn't have an 8-block pulley on it, so that one's lower rating. There's another view. That's actually a different hoist. It's set up a little different where the gear is. This one here is more like what I've got. And then we've got hoist specifications. This talks about, as I could have looked up efficiencies over here. As far as lifting capacities. Looks like 0.8 is a pretty reasonable reduction. That's 16 parts of rope. I don't have that many. That's the style hook I've got. Rope information. And here we have a diagram of the setup of the original drive. So this will be our output gear. And it's keyed to the shaft that runs through it. And then it's turned by this brake section, which comes all the way through, which the pawl energizes one way. So the harder you pull on it, the harder it is to lift the load. The tighter the brake comes on, and the pawl keeps it from being able to go down. And then when you turn it backwards, it loosens the brake off. And that allows this pawl piece to be able to turn separately, and you can lower the load. Of course, as long as the load's heavy enough, it's going to try and force this back, which will re-energize the brake and lock it back. So if you let go of the wheel, it's automatically going to stop and lock, and if the load is on it. Only if the load is really low would it actually be able to keep going down, in which case it's not going to go down because it's got no weight. So these are kind of a self-energizing brake that's commonly used on hoists. It's the same brake setup. It's in those hand hoists that I showed you outside. So that gives me something to go off of if I decide to remake it. Biggest problem I got now would be coming up with these hand wheels. I either have to rob them off the hoist or buy some new ones, but I can't find anybody that makes them in the right diameter. I can get this little one, but this big one I can't find. So if anybody's got a 16.5-inch pitch diameter hand wheel, I'd sure like to have it. So again, this is what we're working with. This will be the original. Would be kind of cool to have it back original. There's not very many manual cable hoists in the country anymore, I don't imagine. Wouldn't be a real big deal because I'm not going to use it at rated load, but maybe a couple times a year. So pulling the hand chain wouldn't be that big of a deal. And then I'm also not sure if I want to run all the electric wire to make this work, because running electric is kind of a pain in the ass too. So what do y'all think? Should I put it back mechanical and build all that, or put a bigger motor on it and get another brake and all new electrical controls and stuff? I did have actually 2 viewers sent me pendants that I can use for the hoist, so that's a possibility. I've had some people say VFD is not the way to go, that it's dangerous on a hoist. I don't know. Looks like to me 10 foot-pounds should be pretty easy to control, and if it's stalled out, the brakes should come on, I would think, unless the VFD keeps it energized. But in which case I still don't know how much it would backfeed through the worm gear and the gearbox. I wish I knew more information about the gearbox and what its design was, or you can actually design worm gears to be self-locking where you can't backfeed through them at all. I don't know if that box is that way or not. It could be, but it could not be, so I really don't know. And there's no info on it that I can find. So I appreciate everybody's input, and thanks for watching.